I will do two things. I will talk a little bit about DBT and introduce the core concepts from DBT that you need to write tests. And then I will share how we set up our DBT projects and the patterns that we apply to write tests. My name is Florian. Probably you can hear it from my accent. I'm German. Yeah, that's all about myself. More important, I work for a company called Flatiron Health. It's located in it's a healthcare company, and we are focused on creating real-world data sets, real-world evidence data sets for oncology. I'm saying this because this matters for the talk, right? So, and when I started working there, I didn't know what real-world evidence means, and I tend to explain it to everyone, if they want or not. So the idea about real-world evidence is that you take data from operational systems, right? So like systems for talking to the insurance, there are like systems where doctors write down their notes, and take the data from those systems and make it available for research. That's the whole idea. There are a lot of reasons to do that. It's not a hiring interview, so I mean, you can talk to me afterwards. But so that means two things. So first of all, we deal with oncology data, and thank you. This is not. I would not say nowadays you would not call it big data anymore. I'm not sure if you would call anything big data nowadays. So what I mean is we don't deal with petabytes of data, right? So like hundreds of gigabytes, but it's not petabytes of data, right? So if you're dealing at that scale, then you might have different problems. But the data models are very complicated. So before I joined Flatiron, I was working for eBay, and there was like the data pipelines I built was counting clicks. I mean, maybe not as simple as that, but it's more like counting simple stuff so I could understand what I'm doing. I'm not a doctor, I don't understand oncology data models, so it's really a challenge. And the second thing, we're dealing with very sensitive data, right? So we cannot just copy all the raw data into our final data warehouse and say, here, all data scientists have fun, right? So of course, we deal with a lot of things, you know, are we allowed to process the data? We need to anonymize the data before we can move it to different environments. And we do this in several countries, in Germany, in Japan, in UK, and USA. So Germany is basically the base for the whole European Union. And thanks to Brexit, we have also an office in London. And so like an engineer from the US cannot access German data and vice versa, right? It's also a bit challenging when you think about building data systems in those segmented environments. Here's a diagram. I'm not going to talk about the architecture. It's just, okay. About the agenda. I have one Smarty Pen slide. It's just one, right? Bear with me. And then we're going to basically look at code. So as I said, I will introduce the core concepts of DBT that are important for us for the testing. And then I will talk about testing. First about data tests and then about unit tests. Okay, let's get started with the Smarty Pen slide. This is the only time I mention a large language model. I thought it's kind of, you have to do it nowadays. The point is, I don't want to talk for a long time about software architecture or data architecture. The point we're trying to make is when you think about testing, testability and observability, if you design your system so it's easy to test and observe your components, you get a lot of other important architectural traits out of the box. So it's, I think, always a good idea to design a system so it's easy to test. And how those things are related is, I think for me, it's especially interesting when you talk about data architecture, because testability and observability are very related to that. And I will talk about this later, or I will mention it again. But basically, we start by data testing the sources, right? This kind of observability. So we like detect, first of all, invalid data or regression in the data when it starts flowing through our pipelines. Then we use unit tests to convince ourselves that the code we wrote makes sense, right? And then we write, again, data tests on the MART layer or like the final layer. Basically, because there we are able to implement domain knowledge into our data tests, right? Yeah, and that's basically, you know, coming a little bit from a DevOps mindset. This is for me like kind of interesting how observability and data testability relate to each other when talking about data pipelines. So that was the only theory slide. You survived that. Let's start with the core concepts of DBT. DBT, right, is an open source library where you can basically, get started pip install DBT, and then you can build data pipelines. You don't need any heavyweight infrastructure, but it also integrates nicely with more heavy. You can add orchestration later. You can run it on data warehouses. So I like DBT, and this is one of the reasons why I like DBT a lot. The first concept we want to cover from DBT are sources. I think it's for every tool that allows you to write data pipelines, you have a way to represent sources. You can hardcore them, but I think it's never a good idea to do that. And with DBT, you have configuration files. Maybe a warning, with DBT, you write probably more YAML than SQL, maybe, so it's like a lot of YAML. Basically, all the configuration is done in YAML files. And so here, this is I think, example database where we have some customer data. And this is such a YAML file for a data source. So there you specify the database and the schema. The first thing, there are a million ways to overwrite this configuration. What works very well for us is whenever we specify sources or database schemas, we always do it with like this syntax. It basically allows you to overwrite this value via an environment variable. Like this, like motivated by this 12-factor app thingy that you basically can always configure pipelines with environment variables. And then you can specify a table and the columns. A recommendation, so if you have like, 3 tables as your data source, you can put everything in one file. But normally that's not the case. So a recommendation is that you have one configuration per table, per source. In this case, you can see we have it organized there as a source folder, and then per data source, per database, data warehouse, you have another folder, and then per table, a YAML file. That works well because those files grow, right? And you don't want to have a file that is 1,000 or 5,000 lines long. Sources, okay, very important concept for building data pipelines. And then we're talking about models. So models are the nodes in the DBT DAG that you build, right? So you build up like this lineage graph, and those nodes, they're called models in DBT. The first important concepts are SQL models, and SQL models are, in the end, SQL files that live in a models directory. So any SQL file that lives in a model directory is a SQL model. You can see that this is not really SQL syntax, right? It's like there's some curly braces going on. So DBT uses the Ginger templating engine. So in the end, DBT is a code generation framework, right? And DBT uses the Ginger template engine to do that. And with those curly phrases, you can reference functions that are either written by yourself or provided by DBT. Here we can we build a staging model and we reference sources with those curly braces source syntax. And you can also reference your own functions. They're called macros. I will talk about them later. Right. So SQL models, basically SQL files using the Ginger templating syntax in your models directory. So next concept are Python models, which is rather new-ish. I think DBT supports Python since 2 years, and some warning. DBT does not execute your code, right? DBT pushes all the computation to your data warehouse. And there are adapters, there are projects that allow you to run DBT in process, but I think they actually have been abandoned, meaning DBT is a tool that you use in conjunction with a data warehouse, right? That's the purpose of DBT. And especially when you want to use Python, you need to have a data warehouse that supports Python, like BigQuery, does the Databricks, Snowflake. I think there's another one, but I forgot that. So Python models are, again, Python files in the models directory. But for Python models, they need to have an entry point. So there needs to be a model function. You can configure to have a different entry point, but why? So like this function has a syntax. You get a DBT object and a session, like a data warehouse session. The session you often don't need, but it's still passed in. And you can return a data frame. And you can return pandas data frames, or you can return the data warehouse native data frames. Like in case of Snowflake, it's a Snowpark data frame, Databricks, like a PySpark data frame, and so on. And then you can use this DBT object to do the same thing what you do with macros in the SQL models. You basically can reference a source by calling the source function on the DBT object. And what you also can do, and this will be important later, You can import your own function and then call them. This is kind of the equivalent to writing your own macros. And this is I will talk about this later, but this code is not as simple as it looks, right? Because this code is executed in your data warehouse. So thinking about package management is not as simple anymore, right? But I will talk about this later. So the next concept is the lineage graph. Basically, by taking the source, those references to sources and to models all together, dbt builds up the DAG or the lineage graph. So when we look at a MART model, we reference some other models with this ref keyword. Then those models can be a Python model, and we use this dbt.source function to reference sources. In those SQL models, we also reference sources with the source macro. And this all together forms the lineage graph, so the way how dbt executes your pipeline. This is an auto-generated documentation. This you get out of the box. So there's a dbt, I think, called docs generate command that will generate a static website with a lot of metadata about your pipeline. It's a very nice thing. And so in our case, we use GitHub. We also deploy this in our GitHub workflow as a static page. So it's a very nice documentation feature to get out of the box. Okay, last concept, and then we're talking about tests, are materializations. Materializations is all about where and how your data is written, right? And the first step is the where, so how can you define where the data is written? There are, again, a lot of different ways to configure this with dbt. This is an opinionated approach. There's a profiles file where you can also specify credentials, which you should use environment variables to do that and not put them into your profiles file, of course. And the same thing goes for the default database and default schema. Here we use the same thing as with sources. We use this environment variable macro to allow us to override the target database and the target schema. And you want to do this basically if you have different environments, a staging, a production testing environment, also for local testing, right? So that's the first thing. You can use this profile YAML file to specify a default database and a default schema where the data is written. And then there's another configuration file. So there are a lot of YAML files, right? If you like YAML, you will like dbt. There's this dbt project YAML file where you can configure add suffixes per model or model folder. So what we do here is for each subfolder of a models directory, so there are staging models, source models, and data warehouse models, we can specify a schema, and this will be added as a suffix to the base schema. So that if the base schema is main, then this would be main underscore staging, main underscore data warehouse. You don't have to do this, but it makes sense if you have a lot of models, then you also can separate in different schemas in your data warehouse. And you can specify the materialization. So how are those models written? dbt by default allows you to configure 4 values. I used here table and view as an example, and there are different considerations why you want to use tables or views or other things. The first thing is a Python model can only be materialized as a table, right? So view makes probably sense. You cannot materialize a Python model as a view. Of course, you want to materialize things as a table that are maybe compute intensive and you query a lot. If you materialize a SQL model as your view, it has the advantage it makes debugging easier, right? So if you can look up the code later, but if you debug your data in a data warehouse, it's of course easy to be able to see the definition of the view, right? Regarding the table, there are actually 2 configurations for materializing table. This thingy will just overwrite the table, right? It's a create or replace what it does in the end. There's also the incremental feature where dbt tries to be smart to detect how it will handle incrementals. There are limits to that, and you can create your own materializations. But normally, like with all frameworks, if you do that, you should question yourself why you're doing that, right? Maybe you can handle this differently with native features. Okay, this was all the core features of dbt that we need for this talk. Then let's jump into testing. The first thing we talk about data tests, and I need to cover another concept. This is the idea of packages. So dbt as a package mechanism it's like Python libraries, right? There's a dbt hub where all packages are listed, and if you take one thing from this talk, then use dbt expectations. It's an amazing package. There's, again, a YAML file where you can basically list all your packages. And DBT Expectations is a port of great expectations, so this Python testing library, to DBT. And what it does, it allows you to test very complex assertions in just 1, 2, or 2, 3 lines of configuration. It's amazing, right? So you can write your own tests, right? And sometimes you have to, but DBT Expectations brings a lot of very useful tests out of the box. I'm not a contributor, so you can take my word. It's amazing. Okay. Let's see this in action. So, as I said, usually how we do this, we run data tests on the sources, basically to test our assumption on the source data, things like constraints and referential integrity and things like that. Then we run unit tests to test our own code, right? And then we run data tests again on the MART level to actually implement domain logic into the test. Things like expected distributions of like biomarkers, right? Things like which you cannot do in the source data. Source data tests. They tend to be simple, right? Or maybe before I'm diving into that, you can have one configuration file, one YAML file where you put all your configuration inside. You should not do this. I think a good pattern is that you have for the sources, as I already said, you have per source a YAML file, and there you can add your data tests. And this is why I said you should have one YAML file per source. So there's, you can have data tests on a column level, table level. I have an example for table level later. So here on a column level, you just have this data test section, and then you specify not null, right? As you might know, most data warehouses do not enforce any constraint, right? So it's your data pipeline has to do that. So you're testing that something is not null. You could use DBT Expectations to test a data type, right? To test that's unique. And also you can test, as I said, the referential integrity. That's like a customer ID should actually reference a customer. Okay. These are the source data tests. As I said, tend to be more simple because, only the transformations that you implement using DBT will allow you to express more complicated domain knowledge in tests. Then do this domain, like test that implement domain knowledge on the MART level. Here, the recommendation is the same thing. You need a configuration file. You can have one gigantic configuration file. I would recommend just per model a configuration file, right? Just by default. I don't think there's a harm in doing that, and it will benefit when your project grows. There you basically reference your model, and there's again a data test section. First on the column level, so we specify the amount column, and then you can have an assumption, okay, it should be between 0 and I think it's 10 million. The amount should be between 0 and 10 million. Then you can use DBT Expectations to start testing distributions, right? You can have a quantile. So this tests that 0.95 quantile or the 95% percentile is at least, let's say it's probably 1 million or 10 million, I can, so this number there. And if you chain those tests, you can start testing the statistical distributions of your data. Then you can also apply tests on the table level, which is useful when you want to combine certain columns into one. For example, simple idea is you can test the uniqueness of a combination of columns. Array construct, this is actually a snowflake feature, but similar constructs exist for every data warehouse. You basically can create a new artificial column out of 2 existing columns, and you test this is unique. And this is an example which I always have to think again about when I try to explain it, but it's like a more sophisticated test. So we again use DBT Expectations, and there's more configuration. So first we have a row condition, so we select rows where the amount is larger than 5 million, I guess, right? So we take all the rows out that have are less or equal to 5 million. Then we construct a new artificial column with the column name, and that's basically what this does. It maps categorical data to a quantitative data. So in this case, just 1 and 0, right? And then we can run our quantile test. So in this case, we say that from all the rows where the amount is larger than 5 million, we expect that 75% of them are in the East region. Yeah. And I think that's very cool, and you can just use four rows to express complicated things like this, or 4 lines. Of course, you can implement this yourself, right, in SQL, but it's just very nice. It goes very fast. So that concludes the part about data tests. Let me just check the time. 20 minutes in. Okay, I will speed up a bit. Sorry for that. So let's talk about SQL model unit tests. Initially, when I thought about this talk in if I was spring this year, I felt very, very smart because DBT did not provide unit tests out of the box. So we wrote our own wrapper or tool that allowed us to write unit tests, and then DBT in June released the unit test feature. I mean, but it's better to use the unit tests out of the box. So I will just show you that. So if you write unit tests, of course, there are two considerations. You first need to know what's the input data and what's the expected output. So the input data, and this allows macros, so the references or the sources. So you need to know, okay, what are the sources of my model? And what's the output, so the columns that come out of the model. And then, again, you guess it, YAML file, right? So you will provide a YAML file where you basically specify unit tests. So you reference your model and you provide 15 minutes more. Oh, awesome, thank you. So you provide input data, fake input data for both sources, and then you would provide expected output data, like this behavioral testing style given when then. One note about the syntax is here I provide the data as SQL. You can do this with CSV or JSON. You can also reference CSV files. I tend to use SQL by default. It's a little bit more verbose, of course, but when you provide the data as JSON or CSV, DBT tries to be overly smart to, create column names and interpret data types. It works in 90% of the cases, but in 10% of the cases, it just creates bugs that are hard to debug. So it creates bugs that are hard to debug. This is why by default tend to use SQL. But it's no hard reason to do that. And I have an example about using, I think, YAML later. So these are the SQL model unit tests. This is more a pattern. This is a way how we do that. So the location, when you look at the SQL test, it's located in a specs folder. There's no harm to put the unit test next to your DBT model or put the unit test configuration into the same configuration file where you also have your data tests. But we like to keep the unit tests all together. So the SQL unit test as well as the Python unit tests. So this is why we put them in a specs folder. And in order that this works, you need to tell DBT, hey, there's not only the models folder, there's also a specs folder that you should look. And again, in this DBT project configuration file, you basically just have to specify the specs folder as a model path. So DBT will look in this model path for models or model configurations. Okay, that was it about SQL testing, unit testing SQL models. I want to quickly talk about macros, but might cut that short. So macros, I mentioned before, are those things that you can reference, those curly braces that you write yourself. And those macros are snippets, SQL snippets that live in a macros folder. And what Ginger basically does is it replaces those curly braces with the snippets defined in your macro, right? And there you can write arbitrary SQL code and reference again like other parameters or macros. So here we pass in order items parameter and we reference it. So this is a reference to a table and we reference this table. Of course, I think there's like a trade-off decision if you want to use macros or more fine granular models, right? So macros are great when you want to, for two things, when you want to reuse code across different models and when you want to test things in isolations, right? So basically when you write unit tests that are very isolated. Of course, you can achieve the same thing with writing more fine granular models, which blows up your DAG. So I think these are trade-off decisions. In our particular case, why we use heavily macros is we implement kind of a variable library with macros. We have different variable types that are the same across different disease types. So we have different cancer types. Some things are similar, some things are not similar. And we have a lot of them. So that macros are very handy for that, right? But I think, having a more fine granular SQL model approach is not bad. Maybe An advantage of using fine granular SQL models is that they are easier to unit test because dbt does not allow you to unit test macros out of the box. So you have to provide some additional files for that. So if you want to test this total amounts macro, we first have to look at what comes out, right? 2 columns, ID and total amount. And then you need to set up some scaffolding code. So we need a test model, like it's a SQL model that just references this macro and nothing else. But we need a reference to another model. And typically you do not want to reference production data. So you have to also set up an input data as a fake model. It doesn't need to contain any data. So you can just reference the columns and the data types that's important. And then like writing a macro unit test is the same as writing a unit test for a SQL model, but basically you reference, you provide fake data for the input and you formulate your expectations to the output. But yeah, so you have to write 2 additional files for that. And yeah, that might be a reason to go for more fine granular SQL files. Another thing, maybe it's like another pattern, is we also not only use a specs folder, but a specs schema. And the reason for that is those artificial files that we create to unit test macros, they will be materialized in a database because also those unit tests, they are executed in your data warehouse. So what we do is we basically put them in a temporary schema, right? And then we materialize them as views, doesn't really matter. And then we have a hook that basically runs at the end of the pipeline that cleans up the schema. Basically, it just drops that schema just for cleaning it up. Okay, that was all about unit testing SQL models. And let's jump to unit testing Python models. And the first thing is, I will come back to what I mentioned earlier. I think the whole trick about unit testing your Python models is creating a package management for your data warehouse, because in the end, then it's just Python code. And I will show you how to do that. So as you, like this is the example from before, we have a Python model that imports a Python function. That's it. So, and the trick about this is how to set this up so it works in your data warehouse. Okay, this is like the Python function. I will skip all that. So the first thing is in your configuration file, in the YAML file for your Python model, you need to configure an import. This, of course, depends on the location on your data warehouse, but every data warehouse that executes Python has a concept for that. In the case of Snowflake, you reference a zip file in a stage, which is just internal object storage. And yeah, so basically what you do here, you tell dbt, please load this functions package from this zip file there, right? This is what you do. Okay, so this is how you can tell dbt to tell the data warehouse where to look up your own Python functions. Now you need to get the files there, and for this we use a hook that runs on the start of the pipeline, and this hook is called deploy packages. It does 3 things. First, it creates a util schema if it does not exist. Then it will recreate a stage, which is just a file storage, right, in your data warehouse. It will recreate the stage packages, and lastly, it will just write the zip file to that stage. Like this, it's like your own Python code is available to the data warehouse. The zip file, I couldn't get dbt to create a zip file, so the zip file is created by our CI, so by our GitHub workflow in our case, but whatever CI infrastructure you use, or you do it by hand, right? And I like this approach a lot because that, you don't have to write user-defined functions, you don't have to mess around with all those kinds of stuff. It's very simple. You just write Python code, have 2 configurations, and your Python code runs in your data warehouse. Yeah. And then when you have your own Python code, right, then you just write a PyTest. So that's as simple as it. You import your function, and then you write a Python, like unit test your Python code. Of course, in many cases, when you think about do you want to write a model as a SQL model, as a Python model, often it's a good idea to write things as a SQL model. It's easier to understand. It tends to be faster. But there is one big advantage of Python. Of course, you have a whole ecosystem of libraries to use, especially when it comes to natural language processing. That's for us the case where we heavily rely on Python models. But also, this is a unit test that runs in your CI. So you can unit test your models without a connection to the data warehouse, which is a very nice thing. Okay, perfect. Yeah, so of course, that your CI can, or that you locally can run this test, your execution environment needs to know that your own package exists. And for that, you just use your own package manager. So in our case, we use Poetry, or this is use Postgre, where you declare your own folder as a source for package code. One last hint, because we declared the specs folder as a source for models, right, to get the SQL unit tests to work. DBT will look in the specs folder for models. There are now Python files, your PyTest files. And DBT will think, there's a Python file, so it's a Python model. So you need to basically tell DBT to ignore the PyTest files. So there's a DBT ignore file. You can basically put the path to your PyTest files in there. Okay, and with that, I'm at the end of my talk. And I will have one more slide where I will show an amazing quote. Having said, this setting works for us. And as Jochen Mader said, a good developer is like a werewolf afraid of silver bullets. So it might not work for you.
So we were exploring DBT for our sort of usage, particularly in Databricks. So one of the features that we liked was the data lineage that it's automatically creating. So you mentioned you're on Snowflake. So what's the sort of the latest pattern that you've seen people using DBT already on, let's say, Databricks or Snowflake, where they have their own catalogs, like Unity Catalog, or I think it's Apache Polaris. So could you talk about how the two work together?
Yeah, so the question was basically how you integrate data catalogs into your DBT pipeline. I cannot speak that this is like the recommended pattern, right? So what we do, actually, we run DBT via an orchestration framework. So basically what we do is we take the DBT DAG and generate, I think we have Dagster as well as Airflow. Those are built, I mean, for Airflow, you need to use Astronomer or something like that, but Dagster have this built in. You basically generate an orchestration framework, and then you use the native, or we use the native library to integrate the data catalog. So it's not a DBT step. Yeah, so it's, does that make sense? Yeah, okay, so, okay, sorry.